Good morning, everyone. Let's get started. We have a lot of things to do this morning. Welcome to the course Cartographic Visualization in GIS, Cartographic Visualization in GIS 2025. This is the second year we are teaching this course. So we have tried to improve a lot of things compared to last year, and there will be still probably room for improvement. My name is Kamiar, or just Kami for short. I'm a lecturer in geoinformatics here at Department of Geosciences and Geography, and a docent in urban informatics. A bit about my background: I have a master's degree in geoinformatics from Aalto University, and a PhD in land use and transportation and land use planning and transportation engineering. And yeah, so I'm teaching. Some of you probably have seen me in GeoPython and AutoGIS courses. These are the three courses I teach right now here. So okay. So this is what we are going to have for today. I will welcome you a bit more to the course. I will tell you a bit about the course and what you can expect. And then we will cover some theories about cartography. Many of you have background in geography, most of you, or geoinformatics. So you have done GIS, you have produced maps. So there are a lot of things about cartography that you know about. But we will have a quick review to see what we already know and what things can be still learned. We will cover some of the design-related matters. These are topics that we are going to open in more depth in coming weeks. But now to get it started already, because already this week we will produce our first map in the exercise. So to get it started, we will cover briefly some of the main topics related to producing maps and cartography. Every week we will have a guest presenter to make things interesting for you and motivate you. People coming from other places, other universities, or some people might be working on the industry side. So for example, we have today Mikael Asikainen presenting. So we will have 1 hour and 15 minutes of lecture by me, and we try to keep it interactive. We will have discussions, and then we will have a 10-minute break around 10:30, and then we will have Mikael's talk. And then today we have a second guest, Anna Saarinen from Aalto University, who is doing her thesis on a very cartography-related interesting topic. So she needs your help, but she wants to talk about her work, but she also wants to do some experiments. So we will also have her presenting the last 5-10 minutes of the lecture today. But before I continue telling you what we are going to do during this period, I would like to briefly know you. The class is quite big. At least 46 students have enrolled. I don't know how many will continue. Maybe half are present now, a bit more than half. We don't have so much time to go in details, getting to know each other. We will do that during the course. But let's just quickly go around, just tell your name and what's your background. And then we will continue. So maybe we can start from here. Okay, nice. We have a very diverse group of students. Well, I say welcome to you all again to the course. Yeah, so we have very diverse backgrounds. Hopefully there will be something for all of you here. But let's continue now. We introduce the course staff. I already introduced myself. I will be the main lecturer for the course. Tatu Leppämäki will be also helping us, doing mostly the tutorials. You can maybe introduce yourself a bit.
Yeah, hi, I'm Tatu. I'm a PhD student here at the Digital Geography Lab, so also geography background and geoinformatics background. And yeah, I've been developing the materials for the tutorials, so where you learn to use the tools. Kamera will soon tell you how that thing works, but yeah, so introduce some of these tricks and tools for you to do. And yeah, this year we've been doing them sort of recording the videos, so you'll be seeing me through those videos if you watch them. And then I'll probably also appear on these sort of exercise classes. So help out with that. Of course, if you have any questions, then feel free to ask me, approach me on Discord or elsewhere. So yeah, nice to have you here.
Okay, thanks, Tatu, and it's great to have you on board. We also have Maija Havusela working as the course assistant in this course. She couldn't make it today, but she will be there helping you with your exercises every Tuesday. So this is the courses staff. What is the course format? You already know it's a 5-credit course. We have lectures every Tuesday, same time as now, so from 9:15 to 11:45 with a small break in between. So what we generally do is that we have a lecture in the first part of the course, and then we have a break, and then we have a guest talk, and then we continue with discussion. So that's the structure of our lectures, our Tuesday lectures. Then we have tutorials that are released as recordings on course's website every Tuesday. So it's a video published on YouTube and shared on the course's website. So what we used to do last year was that we had the tutorials in a GIS lab in person, but there were too many meetings every week, so we decided, and most of the students were not showing up because it wasn't obligatory. So we decided to just have it as recordings this year, and let's see how that works. But the tutorials are published at the same time as the lecture, so now they're already on the website. So the idea is that in the lectures, you will learn the theory. So it will be mostly theory, talking about cartography and discussing related topics. And then in the tutorials, we show you, as Tatu already said, we show you some tricks how to make nice maps. So we have some data we're working on. We make some maps. I will do the Python version of the course, and Tatu will mostly do the QGIS part, and I will shortly explain what I mean by these two different tracks. So that's the idea. Then we have an exercise which is not the same as the tutorial, but hopefully what you have learned in the tutorial, some of the tricks you have learned would help you to make a better map in your exercise. So the exercise could look a bit different from the tutorial. It does look different, but the idea is that you can use the learnings from the tutorials to make a better map that week. Then we have help sessions on Wednesdays in the GIS labs here in physical, in the morning and in the afternoon. So you can show up at either of them. So these are optional. About attendance, I've gotten already a few emails. Attendance is not obligatory, so if you do not attend the lectures, you're not going to fail in the course. But I will explain the grading a bit later on. Part of your grade will be active participation in the class and like how you perform in the class. So if you're not present, of course, you will miss some grade from there. But there are students who are having summer jobs or cannot make it. They can still do the course, but it won't be as easy for them. So that's the structure of the course. Then I already sent you a pre-assignment. Some of you, I heard, didn't have access to Moodle. We will hopefully fix that. But many of you participated in the poll. So I ask you whether you're interested in doing the course the Python way or the QGIS way. I checked the results this morning. In Moodle, they appear with names, so I'm not going to show it now here. But around 8 or 9 students had said that they want to do it with QGIS. The majority were saying that they want to do a combination of the two. And there were a few people who were not sure. Hopefully, you will have some idea by the end of today. And yeah, there were just few people who wanted to do it like purely with Python. So the idea is that you can choose what you want to do. Some of you are more comfortable with programming, so you can just use Python and create the maps. Some of you prefer to use the software, and the software we are using is QGIS, so we have tutorials and support on both of them. So you can choose to go either way, and many students last year chose to do a combination of both. So some exercises they use Python, in some exercises they use QGIS, or it was a mixture of both. So it's up to you what works best, but we promote both of them in this course. They are both useful tools, so it's up to you which one works best for you. But today we will talk about this more, so hopefully you will get some idea which track you want to take. But this is non-binding, so you don't have to tell us whether you want to do the Python version or the QGIS version of the course. And as I said, you can jump between the two during the course. The course environment. So we have CSC NOPE. Many of you have taken, yeah.
Sorry, just one more thing. I think it's also fine. I think last year some people did it with R or used some other tool that they're familiar with, or if you use like graphical, like software, like let's say you're familiar with Photoshop. So you can always use those if you prefer the exercises. But then of course we won't be able to help those probably. So then
yeah.
So then we want to have what if you are familiar and comfortable with those and you want to really try them out. So then I think you're also free to do.
Yeah. Very good point. Yeah, so you have free hands what tools you want to use. We will support you in the ways we know. I'm familiar with Python, Tatu is familiar with Python and QGIS. But of course, you can, if there's some other tool you want to use, you're free to do that. So many of you have taken the AutoGIS and GeoPython courses. You're probably familiar with the CSC Noppe, or formerly known as Notebook environment, where we run Jupyter Lab. So for those of you that are doing the Python version, of course, you can make the Python environment locally on your own computers, or use whatever environment you want. But for your convenience, we have also created an environment on Noppe, and it has all the libraries that we actually introduce in the course. But yeah, so that's the environment. We also use it for delivering materials. Is that so, Tatu? Do you use Noppe for QGIS at all?
Well, you don't need to run anything on it, but it might be easy way to get access to the sort of notebook. So even for the QGIS exercises, the tutorials of the instructions are presented in this notebook format. So, but you don't need to run anything in the notebook itself. It's just an easy way to sort of give you instructions. So yeah, you can do that, or then you can follow along on the website itself, or then check out the GitHub pages, or whichever you choose.
Yeah. So another question we often get is that some people do not like programming, or they're not comfortable with that, and they ask, can they complete this course if they don't know Python? And the answer is yes, because you can go the QGIS way. But if you choose to go the Python way, it means that you are already familiar with Python, because we do not teach programming. We just show tricks how to make maps with Python in a bit better way. So that's Notepad and Courses website you're already familiar with. We publish the slides and recordings on the Courses website. One thing I forgot to mention is that we are recording the lecture, and we will cut out the part that you introduce yourself. But we are recording the lecture, and this will be published on the Courses website today or latest tomorrow. So if you miss a lecture, you can still follow. But for the guest lecturers, some guest lecturers do not want to be recorded. For example, our guest today does not want to be recorded. So we can't guarantee that everything will be on the website. But at least the parts that are from us, they will be published on the course's website. Then we have Moodle. Moodle, we basically use it for submitting the assignments and the final project. And yeah, maybe some announcements. But most of our communication will happen via Discord, and I've shared an invitation link with you already on Saturday. So we will be in touch there. So the grading works like this. We have 4 exercises, 1 exercise each week, accounting for 10% of your overall grade. And then we have a final portfolio that we will talk about later on during this month. And that will be 40% of your grade. And then we have other merits, 20%, and that is coming from your class activity. It means presence and how active you are, and wide use of cartographic tools, because many of us know how to make maps. And what we saw last year was that, okay, they just quickly export something from QGIS, and that's not what we want to do. We want to try out different tools and be a bit creative. So that's why we have, you will be rewarded also for being a bit more creative and working hard to improve the maps that you already knew how to make. So that's how the grading works. Do you have any questions about the course and how we do things? Yeah. Did I miss anything, or?
No, I think that was...
Okay. Okay. If not, then we can continue with the actual materials for today. But one thing I can quickly do before we continue is to show you the courses website. Probably you have looked at it already. There's a lot of information about the course. So like the structure, the topics of every week. Things might still change a bit, especially because we have some guests visiting us. But you can get some idea who we are going to have on the course and what topics we are covering. In the general information, you can see same things I just showed you on the slide, more information about us and the links to the environments you're using in this course. And for CSC Noppe, for joining, you need a code, and that's the code you're gonna need for joining the Noppe environment. In the first tutorial in the Python version, I have gone through this, so you will see how this works. if you haven't done it before. There is some information about the environment, and if you want to create your Python environment locally, there are some instructions here taken from the AutoGIS course. Grading, we already covered that, learning goals. Yeah, and other information that you might find useful. So before I continue with these slides, I would like to quickly show you one page of the course's website. And here in detail, we talk about programming versus GIS. And that's a question that you might have because you want to know how to continue in this course. So Python for cartography, there are pros and cons. So if you ask me which one is the best, I would say, well, as a cartographer, you should have you have a toolbox, you have different tools, and you should, if you want to be really good at making maps, then you should have a toolbox that has more than one tool. So if you only can produce a map in QGIS, then you're very limited with what you can do. But if you have in your toolbox also Python or other tools that you can create for map, then you are able to produce better maps, a wider range of maps. So there are pros and cons for each of them. So as you know, with programming, you are more flexible. You can integrate your work in different workflows. You can combine your work with like ArcGIS or QGIS because both of them work with Python. So you have a lot of flexibility. Then you have access to a wealth of libraries, a wide range of libraries that are usually open source. You can just use them for customizing your map. So basically, there is no limit what you can do if you are creating a map with programming. Another motivation for many of us using Python for GIS, and in this case, cartography, is automation of tasks. This is maybe something that Mikael will talk about later today, that if you need to produce the same kind of map over and over, then doing this in QGIS or any software is a tedious task. So one motivation for you to use Python or any other programming language for cartography is the case where you want to reproduce a map. It can be the same map if you're selling the map or you're, I don't know, for whatever reason, you're reproducing it many times. Or it might be a different map, similar map with similar layout and everything, but from, for example, different neighborhoods in Helsinki. But you want to use the same parameters and everything. So if it is a Python code or any other code, then you can just run this quickly every time. But of course, with software, it takes a bit of more time. But there are also limitations or some cons with programming. The learning curve is a bit steep. If you're not very comfortable with Python or programming, of course, it takes a bit longer compared to software. It's less visual. We are so used to using this software like QGIS, ArcGIS, where if you have a user interface, you can just play with the layout, move things around, copy and paste, and this kind of things. Of course, in Python, you don't have that visual interactive environment, so that might make it a bit tricky for some. And of course, you have to do things more yourself. Many tools that are readily available in those software packages, you have to do them manually yourself in your code. Same with software. They have pros. They're easy. They're user-friendly. There are many plugins, for example, in QGIS that you can use. There's community support, but there are also limitations. For example, well, I'm sure you have been in the situation that you want to do a certain kind of visualization, a certain kind of task in QGIS, ArcGIS, and simply there is no way of doing that. Unless you write your own code or you integrate your code within QGIS, then using the ready buttons there, you may not be able to do everything. So these are the limitations. So that's why for many of us who do GIS, do cartography, including the students we have had in this course last year, a combination of the two has proven to be the most efficient path to take. But that's up to you. You will figure out yourself what is best for you. Okay, so now we actually start with the contents from today. So the main question, probably you know the answer already. That's why you're sitting here trying to learn cartography. Why do we want to visualize? It's a famous saying that a picture is worth 1,000 words. Many have probably been in a situation that you want to describe something, and describing something in words is often very difficult. Like you might need to use hundreds or thousands of words to describe something, And even then, your description may not be as accurate as just showing a picture to the person. So that's why visualization is important, and that's not limited to only geographical data. A visual representation can reveal things that numbers do not do, and we will see the famous example from Anscombe Quartet on the next slide. A geographic map, this is particularly relevant to GIS, to geographic data, because we are working with numbers. So even if you have qualitative data, if it is GIS data set, it means you have coordinates. So in essence, it's always partly quantitative. And when working with numbers, visualization can do magic. So that's especially important. Another reason why it's particularly important to cartography and GIS is that in geography, many things are about the spatial relationships. So how far something, object A is from object B, or what is the distribution, what is the pattern, what is the trend in your data, how does the density change? So these are the questions we deal with very often with geographic data. And these are things that you can visualize very effectively. And it's usually more effective than just describing things. As a result, maps have been an important communication and decision support tool in a very long time. So this is the Anscombe Quartet example. So if we created this decades ago, and it's very smart, so you might have seen this before. So there are 4 data sets that look identical if you just run some statistical analysis. So if you just look at the average, the variance, and correlation, or apply a linear regression on them, it looks almost identical. So if you just purely look at the numbers, well, looking at this, it's a bit hard to understand anything. And if you just do something quantitatively on a simple level, you might think that, okay, these data sets are very similar. But when you actually visualize them, you can see these are nothing alike. So they are very different patterns. So that's an important, there's a good example showing that numbers can not tell you the whole story sometimes. So visualization can complement your understanding of your data. And this is a very good example of that. So what is cartography? Cartography is the art, science, and technology of making maps. Historically, maps have been used for a wide range of purposes. So this is one of the things that has changed drastically during the centuries, because cartography is very old, even if they haven't used the same term. Always, it's an old term, but even if they haven't specifically used the term, maps have been around for thousands of years, if not longer. But at the beginning, they served different purposes. So one of the main motivations for creating maps in the first place was for storing geospatial data. So they made a map to know where they can find, for example, water, or where there is a certain mountain or certain element they needed on a daily basis. Nowadays, it's a bit hard to imagine because we don't think of maps as a place where you would store your data, because we have all these computers and storage devices. But imagine in a day where there was no computer, to remember where a certain geographical feature is, you had to draw a map and keep it somewhere. So it was one of the main motivations was that maps are a way to store geographical data. But also another major motivation was for navigation, and this has changed a lot throughout the centuries. So when humans started to be more mobile, when they started exploring the seas, navigation was a very big motivation to create maps that are good enough to be used for traveling around. And of course, it's been used for planning, territorial claims, and also it has been a work of art. For example, we have examples of that during Middle Ages, where, well, the maps were not, in some cases, super accurate. They were made for more like artistic or religious purposes. So we have examples of that. Maps are powerful. They can shape our perceptions of space and place. You might have noticed that well, we have been using maps so much. Now for navigation, we use maps so much that you actually, when you think about places or navigating somewhere, like going around in Helsinki, what you might imagine is a picture from OSM or Google Maps when you're thinking, how do I go from point A to point B? So we have used maps so much that it has almost shaped our understanding of space. So when you think about Helsinki or how to go around, you might think of the map. rather than how the streets look like. And they have influenced routes and exploration. Many places around the globe were explored more compared to some other places, basically because we had maps of them. So whoever was traveling knew that this place exists, and they went there. And of course, they have been used historically for asserting political control. So as I said, they used to be a way for storing geospatial data. Nowadays, they are mostly used for communication, and this communication is not only for others, with others. So you might have a data set, you do your thesis, you are working in a company or somewhere, you analyze your data, you make a map, and you want to communicate that with whoever you're presenting your work to. But sometimes you just want to communicate the data, the information from data with yourself. So you're looking at a data set, and you don't understand fully what is happening there. You visualize it, and this is a way of communicating with the data. So many of you have hopefully watched the video I shared. How many of you have watched the video? Can you raise your hand? So most of you. So I won't go through details of cartography from a historical point of view because you watched that video. But evolution of cartography. So cartography is a mixture of these things nowadays. So different times, depending on what our needs were or what tools were available to us, we have emphasized some of these. But nowadays, it's a combination of these things. So we use it for presentation. Of course, that's one obvious use case for visualizing and making maps. We also use it for synthesis. So very often in GIS world, we have different layers of data. And combining them on a map or doing different kinds of map overlay is a very powerful tool that has been used even before computers. They did overlays manually using certain papers or certain tools. So synthesis has been important. If you can do visual analysis, there are like courses on visual analysis that you can just learn how to use maps to analyze your data and understand things from your data. So it can be seen as a tool for analyzing your data. And of course, you can use maps to explore your data. That's another obvious use case. And the more we have more advanced technologies, such as like interactive maps that are not so new anymore, they have been around for decades already, the more we can use visualization to explore our data, do analysis, and do things. So it's been changing all the time, and it will continue changing, the cartographic landscape. So you watched the video, so I won't go through this in detail, but the maps have been around for a very long time and with different purposes, and it's been changing a lot. So we have the prehistoric times, from cave paintings to clay tablets, and they were basically early special representations of places. We have some early examples of world maps. They are not, well, you cannot use these to go from anywhere to anywhere, but they already showed curiosity of people for understanding the world. Then we have the medieval worldview, which was heavily influenced by religion. Then we have the Renaissance mapping. That was the age of discovery when they started like exploring the seas, traveling around. So navigation became a very major driving force for developing better and better maps. So you start to have better, more accurate maps that you can actually use for navigation. And then we have the Enlightenment era cartography, where we have more rationalism and empiricism. So maps start to be more accurate. That's the time that we started to do surveying in a more systematic, methodological way. So we started to produce better, more accurate maps. Then we have the modern cartography, and that's when the GIS was born. So we have the software, the systems that we use for producing maps. So that made a huge change. This is something we are going to discuss next week when we discuss cartography as an art. We will talk about the implications of these modern technologies on cartography. How does it affect cartography as an art if you can just produce something by clicking something in a software? But these methodologies have changed the landscape for cartography quite significantly. And nowadays we have, this is some topic we will revisit on the last week, what are the trends in cartography now. We know there are new tools coming all the time. AI is very topical nowadays, so AI is also affecting cartography and how we create maps. So we are going to visit that topic later on during this course. Another topical thing in the world of GIS, geography, is the crowdsourcing. You have all these huge sources of data appearing from different sources, and that has also shaped a lot the landscape for cartography. But we will revisit this topic. So what is the first step for making a map? Well, of course, let's assume that you already have your data and you have cleaned your data. We are not going to go there. You all know GIS. You have used data analysis. So assuming that you have a good data to begin with, one of the first steps to take is figuring out the coordinate system and projection. So this may not appear as the most obvious part of cartography. Many of you have studied projection systems and coordinate systems in other GIS courses, geography courses. So it may not seem very obvious, but it has very significant implications on the maps you create. So this is something that we briefly cover now. So we don't go through details because there are a lot of details related to this, but we just want to raise awareness. So we want to remind you that it's important to think about this when creating your map. So as you know, the world is not flat, unlike what many people still believe. So to create a map, but the maps we create nowadays are usually two-dimensional. There are exceptional examples where you're using a fancy device or something to have some 3D visualization. But in most cases, whether it's on a paper or on your computer screen, you're having the map presented in two-dimensional. And that's a problem because, as we know, the world is 3D and we are living actually on a globe. So what we need to do is to very often, well, always when we're producing a map, we have to project the 3D world, the 3D globe, into a 2D surface so we can visualize it using the devices we have. So our life as cartographers maybe would have been easier if we were living on a flat surface, but that's not the case, so we have to live with it. So this has been a challenge by many cartographers, or actually mostly from mathematicians, figuring out how you can project a 2D surface, a 3D surface into two-dimensional surface. And there have been many attempts. So if you search, if you just browse what coordinate systems or projection systems are available in just QGIS, you will see there's a long list of hundreds. And if you do a historical review, you will simply see there are thousands of projections you can choose from, many of which are obsolete or they are specific to certain areas around the world. But there has been a lot of attempts, and that's why we have a long list of coordinate and projection systems we can choose from. So two things to distinguish here and not get confused with. We have coordinate system, we have the geographic coordinate system, and then we have a projected coordinate system. So the coordinate system, the geographic coordinate system is not projected by default. So it just tells you how you have calculated the coordinates. So what are the axes for your measurements? What is the unit? What is the datum or the shape of the Earth that you have used? And that's it. But very often for creating maps, we need to have a projected coordinate system. So these are different. So with projection, you always have to lose something. Of course, you're bringing your data from 3D to 2D. So you cannot do magic. You have to always have some compromise. You lose something and preserve something else. So no projection is perfect. That's why very often when we are just collecting data, well, it depends on scale and many other factors, but if you want to just preserve the data without visualizing, very often we do not project it. So we keep it in the original geographic coordinate system, because when you do the projection, you lose something. But for cartography, we need to do projection, and we need to know a few things in order to make a wise choice regarding what projection system we want to use. So there are a few important elements in our map, and we should be familiar with them. And these are things that are going to be affected by the projection. So we have areas, like how big a certain country is, or how big a certain area is, whatever that area is. We have angles between different features. We have directions, where is north, where is south. And we have distances on the map. So these are some of the elements that we use in the map quite a lot. So you want to read distances or check out the areas of places. And these are things that can get distorted, will get distorted with your projection. So depending on what's the purpose of your map, what is the scale at which you're producing the map, what is the directionality, what's the location, and how familiar you are with the area, there are a number of factors that you should take into account. And based on those, you can make some decision. And these are the decisions that are available to you. There are different kinds of projection that you can choose from. So we won't go through details of this. There's a lot of material everywhere and GIS books, so you can read about them. But just simply said, we have cylindrical projections, we have conic projections and azimuthal projections. So what matters most when you're choosing your projection, this is a bit of small text, so it's a bit hard to read, is that you choose a projection depending on what you want to do. What would it preserve? So if you go with a conformal projection, it will preserve the angles, making them ideal for navigation and, for example, weather maps. So conformal projections will preserve the angles. So if you want to navigate on the sea, angles are important for you. Otherwise, you end up somewhere wrong. But the areas are not important for you. So if the map is for navigating the seas, traveling around the seas, you don't care how big a certain place is as long as the angles are right and the map can take you from point A to point B. Then we have equal area projections that preserve the areas, but they mess up with, for example, the angle in your map. So these are not good for navigation, but if you are making a map of, let's say, Europe, and your point is to show how big the countries are compared to each other, then you want to go with a projection that preserves the areas because that's the point of your map. Then we have equidistance projections that preserve the distances. Depending on what you want to do, that might be something that you want to preserve. And there are also compromise projections that are a mix of different things. So again, for some general purpose maps, you might want to go with some compromise projection. There are some more details about this, but that you can read on your own. But a few important things. Nowadays, we are overly using Mercator projection. And that's a problem. It actually has shaped our, well, most of us are here geographers, or we have studied geoinformatics, so we know the world a bit more better than many. But to many people, this is how they see the world, because they have seen online maps, they have seen Google Maps, and that's how they have learned about the world. And online maps use this web Mercator projection. And Mercator is a cylindrical projection system that works best in equator areas. It preserves angles. So it was good before for navigating. It is still used for navigation. But then later on, it was adopted by online maps like Google Maps, OSM, and many more to create online maps. So since they have been widely used, they have shaped our understanding of places. But they create a lot of area distortion, especially around the two poles. So as you can see, this is how Mercator projection looks. That Greenland actually looks bigger than South America, which is not the case. It's just heavily exaggerated. So that's why many geographers don't like Mercator for that purpose, because it just distorts our understanding of the world. And the reason why this is overly used is that, well, there are established habits. It's like everyone creates a map in a certain projection system. It doesn't have to be Mercator or Web Mercator, but anything. You just start working somewhere and you see everyone is using the same coordinate system, so it's easy to just adopt the same because it's popular. And there's also a lack of knowledge. Very often maps nowadays are produced by people who are not geoinformatics experts or geographers. So they just use QGIS, they have learned QGIS or some software, they just produce a map without thinking about projection, because by default, they do some projection for you. So many don't think about it. So it is important to know what are the norms, what is recommended in your study area to create the map, but you should be aware of what you're doing. So in Finland, what we often use is the the coordinate system used is this EUREFIN based on European Terrestrial Reference System 1989, ETRS 89. And the projected coordinate system we use is this TM35 fin, which is a transverse Mercator projection. So it's a transverse cylinder applied to the Earth. So it's more suitable for Finland, which is closer to the pole, compared to the regular Mercator. So this is what we often use in Finland, and this is the recommendation. But of course, you can have data sets coming in different projection systems. What matters is that you know what you're making the map for and make a wise choice. Before we continue, let's have a bit of activity. Scan this with your phone or just type in the URL. It's an empty Flingo board. And what you need to do is to add sticky notes, as many as you want, and write what you think would make a good map. So it can be anything that you think would contribute to making a good map. So let's take a few minutes and add a few things there. I will also pass around the attendance list. Like I said, it's not obligatory to be here, but it's part of grading, kind of. So. Okay, you can still add things to the board, but at the same time, I can start going through them so we don't run out of time. yeah, so according to you, some of the things that help make a map better. So simplification, that is true. Of course, it depends on what kind of simplification. Sometimes you need to simplify a feature. For example, if you're making a map of a river for a general purpose map, not a map that you would use for hiking or navigating, then simplifying features helps. Simplification might also mean not overcrowding your map. So you might have different layers of data, different elements that you may want to include your map, but you should ask yourself, do I need to include all of them? So keeping your map simple is a good point. Informative but not misleading. Yeah, so in cartography we want to make nice maps. This is something we are going to learn during this course, but that should not come at the price of making incorrect maps, so that's very true. Clear boundary lines. Yeah, the features, visual variables that we will talk about today. Adding title or text, readable text, so taking care of being careful with like visuals on your map are important. Coordinate system, we talked about that. Simplicity and clarity has come up again. What is recommended in your field of study? That's a very important thing, to be familiar. So very often you find it easier to make a map of a place and a phenomenon that is familiar for you. So if it's a topic you're not very familiar with, of course, if you're a very good cartographer, you do your research, you create your map, but you will find it easier if you're familiar with the context, with the topic, with the phenomenon you're mapping. It's much easier. Like before I started, like personal experience, before I started here as a lecturer, I was working for a while in Singapore somewhere. So it was very difficult for me to like produce maps at the beginning because I had to do research on everything. I didn't know areas. I didn't know what coordinate system works best in that area. So if you're familiar or get familiar with the place and phenomenon, it gets better. Know the audience. It's very important, knowing who you are making the map for. Also the purpose of the map. What are you making the map for? Is it a map for metro? Or is it a map that if people are going to use to like travel around? So, or go hiking. So the level of details and many decisions you take depend on the audience and the purpose of the map. Suitable scale, adding legend, informative legend, and any other elements that you find important to the map and understanding of the map. Not too much information, yeah, not overcrowding your map, adding labels and other elements. So what we can conclude from here is that a few things came up. So knowing the audience and the purpose of the map, being familiar with the topic and the context and whatever you are mapping, and what else? Taking care of being careful with visual elements, so not overcrowding, choosing right colors, correct layout, many visual elements that we should be careful with. So let's continue with our slides, and we are going to open up many of these in more detail. As I said, during this course, we will go with back and forth between many of these things, so we will dive a bit deeper into this later on. But let's have a review of the cartography. So if you want to make a good map, you should try to follow the cartographic grammar as much as possible. So that is a term that is very often used in cartography books. So it refers to cartographic rules and guidelines. So one of the reasons why maps produced by people who are not educated in GIS, geography, cartography relevant fields is that they rely on software. The software allows you to apply this cartographic grammar, but it doesn't do it automatically. So it allows you to choose the right title or choose the right layout, but it doesn't do it automatically. So if you're not familiar with cartographic grammar or what are the rules, what are some of the best practices that make the map look better or more correct, then having a good software is not enough. So another thing that is important is the map elements. So one thing that we have been taught, especially if you have taken like cartography courses 10, 15 years ago, is that we were taught that is like map elements were overly emphasized, meaning that there are a certain number of elements that are important. Every map should have a legend, every map should have a title, every map should have a north arrow. very often it's the case, but it really depends on the kind of map. So it doesn't mean that you should just by default put a north arrow in every map you produce, or not every map you produce needs to have a title. So map elements are important, but this also means that it's important to know what mapping elements you should include, not just put everything that is available to you. Yeah, so these allow you to make maps that are usable. So this map is an actual map from somewhere in Finland. It's a real area. But if you just look at the map, it doesn't really tell you much because it's not following the cartographic grammar. You have elements. You don't have enough elements. So you have the map features, but you don't, for example, have a legend. So the colors do not tell you anything. Yeah, you can guess. The blue is probably a lake somewhere. I don't know what the lines are, maybe some stream of water, but you can't really understand what are all those colors. So without map elements and following cartographic grammar, the map is not necessarily very usable. So the map elements, like this is a short list. We will see a longer list of the elements that you often need to include, like some of them in your map. Well, the map itself is an element. So you should think of the map as an element, and we work on it. So where do you place it? How should it be placed? What is the scale? So these are some of the things that you should consider when making the map. Then title, legend, scale, orientation, metadata. So as I said, depending on what you're doing, you may not need all of this. So a scale is not always necessary. So if you're making a map for metro lines, you really don't need to have scale in your map. So it really depends on what you're doing. Depending on what you're doing, you choose them. Yeah.
Just what do you mean exactly by index map?
Yeah, so index map is also a very specific kind of map. It's from very large areas. So there are many sheets of map, and the maps are indexed. So you add the index so you can follow the number and look at another map. So this was particularly common when we had these paper maps, where you had many layers of map, because now you can easily browse between different layers, but still they exist. So index is considered classically in many cartography books as one of the elements, but it's a very specific kind of element that you would only need in certain kinds of maps. Another thing that is a good addition to maps very often, again, depending on what you're doing, is inset maps. So you're making a map of Finland for your journal article that is going to be read by people from all around the world that may not be very familiar with Northern Europe specifically. So it's very common when you have an international audience, then you would include an inset map. So you will show where Finland is located on the globe and where is Helsinki in Finland. So this is another element that is widely used. Again, if you look at cartography books, there is a very long list of elements that exist and you can use, and this is a wider list of them. So we have some primary elements, and then we have secondary elements that are a bit more specific to certain maps. But yeah, titles are some things that we often use. Legend is very often important. Then the map itself, north arrow depends on the kind of map. Date might be relevant to include. Authorship, scale bar, and metadata is also one thing that is important. And this exercise today, you are going to create a map. So for example, in that map, you have the freedom of choosing what data to use. So we haven't given you any specific data. So in that case, for instance, metadata is important, because if I'm looking at your map, I should know where the data is coming from so I can understand or trust the map a little bit better. Then we have map symbols. These are used to represent items. So we have different geometries that in maps that we use symbols to represent them. We, of course, work with points. Very many features that we show on a map are points, simply referring to places. We have lines, areas, surfaces, and in some cases, you might have some complex three-dimensional object. So symbol types that we can choose from, we have pictures that are pictures of places. In one of our exercises, we will see how we can use pictures instead of symbols. So you are mapping residential areas, or you're mapping people's homes. So you have respondents from different areas, and you want to map where they come from. So you might just put a picture, a symbol of a home, and that's a picture. So it's very self-explanatory. It's representing home. Sometimes the symbols you're using are associative. So that cross, can you guess what it refers to? If you see it on a map without a legend, what's your best guess? A hospital. So it doesn't really have much to do with a hospital, but because of all the maps we have been exposed and all the materials, it somehow just reminds that this is probably a hospital. So it's associative. It's just associated with a hospital. These are also very commonly used, but you have to be a bit careful with them because these associations are also very like context specific. So I don't know exactly, but maybe if you go to another part of the world, this cross may not necessarily tell them that this is a hospital. So it's a bit context specific. You have to be, or very often on maps, you're mapping worship places, like religious places. Of course, this is also very context specific. So you have to be careful. Do really people associate that symbol with what you assume they would be associating with? So then we have also abstract symbols. For example, the pins, they don't really show anything, but it's an abstract item pointing to a certain place, for instance. Symbols can vary to show different object classes and attributes, and that leads us to the topic of visual variables, which is very often discussed in cartographic courses. There are different versions of this, but the original version, this is like the older version of it, comes from a book, old book in cartography by Jacques Bertin, and the term was coined by him back in '67. So the term visual variable is commonly used to describe the various perceived differences in map symbols. So very often you have one thing is that you have different elements. So you have homes you're mapping, you have worship places, you have hospitals, so you have different symbols for them. But very often you also have another value attached to that symbol. So how big is the hospital? Like what is the capacity of that hospital? And you want to represent that somehow. So there are a number of ways how you can do that. So for example, the size of the symbol, the same cross we saw, can be proportional to the capacity of the hospital or how big a school is. So these are the visual variables you can use to visualize more things without overcrowding your map. So instead of adding the number next to the symbol showing how many people or what is the capacity of a hospital, you can just use one of these visual variables. And there are a number of them. So size is one that is commonly used. You can use different shapes. You can use different color hues to show different things. You can adjust the level of brightness. For example, this is something you see often in heat maps. It can be different levels of brightness or saturation showing different levels of density. Then you can work with direction if direction is something that you're showing in the map. And yeah, and nowadays there's a longer list of this because now we also have, for example, 3D maps, we have interactive maps on the web, so you can see different versions of this nowadays. So this is a good map. It's already old, from 2017, showing the tram lines in Helsinki. We will get back to this later when we talk about colors, so it's not perfect. It has things that can be improved, but it's a good example of how different visual variables can be used to show different things. So look at how colors are used differently to show different lines, or how the train line is distinguished with tram lines by using some kind of pattern. So yeah, so this is a good example of using visual variables, but just not spending so much time on this. Is there something you particularly like or dislike about this map?
I like how the colors are combined in like different main groups, like there it's green and like colors like purplish and like one is bluish, so you can like follow the main color of the color and then one of them.
Yeah, that's a good point. Anything else? Yeah.
It's good that the background is kind of like the colors aren't that intensive, so you see what's in the background, but they don't out
Yeah, that's also a good point. Anything else? Yeah, so there are a lot of things that work nicely with how visual variables are used here. We will revisit this next week and we will see there are things that can be improved. For example, if you have people who are colorblind, this map may not be ideal. So this combination of using like red and green in a map is going to be tricky. So it could be, there are things that could be still done better. But overall, it was a good example of how things work. Speaking of web maps, very often what we talk about is the maps that you would print or export as an static map. We have one whole lecture and a tutorial and exercise on interactive maps. So we will revisit this, but just as a quick reminder, interactive maps have also like certain elements that are specific to them. So you have a zoom button, zooming, like you can interact with the map. There's a zoom button, there can be a search box, there can be different elements that are very specific to an interactive map. So if you are making an interactive map, beware that elements are a bit different. So about types of maps, and today we already make one thematic map. So generally speaking, we have two types of maps. We have thematic maps that show data relating to a particular theme or topic, for example, land use or car accidents or population. Then we have topographic maps that contain a diverse set of data. These are just more general purpose maps where we have different layers of data combined. So they are less specific. So very often now, of course, it depends on where you're working and what you're doing, but we see thematic maps more often nowadays, but we also have topographic maps. So thematic maps, these are the classification that you have probably seen in other courses, and you see it in cartographic books. We have choropleth map. This is a very common kind of map that you see. We have dot maps or dot density maps. The number of dots, the density of the dots would represent something, for example, very often population somewhere. Graduated symbol colors, like the example I said about the capacity of hospitals, you would adjust the size of the symbol to present some value. We have heat maps, we have cartograms, flow maps, and isoline maps. And a few of these we are going to create during this course. So we are, for example, going to create a flow map, a cartogram, a heat map, and choropleth maps. So these are just a few examples. So if you ask me what makes a good map, this is my answer to you. So what is a good map is, first of all, the understanding of what makes a map good. So those cartographic grammar, and of course coupled with your taste and creativity. So knowing what would make a map nice, that's the first thing. But that's not enough. You should also have the technical skills to implement. So if you just know, okay, this map would look nice if I do this and that, but you don't have the tools or skills to do that, well, it's not enough. Then you will end up probably making a simple, lazy map. So this is what we are aiming for. During our lectures, we try to understand what makes a good map. And then in tutorials and exercises, we are seeing, okay, how can we use our technical skills or develop our technical skills to implement those ideas. But to make a understanding what a good map is, and this is something we're going to work on for months during this course, is a number of things that came up actually in your Flinga notes. So knowing the user is very important. Who are you making the map for? Culture and context, like I said, important in many ways. For example, when you're choosing symbols. The purpose of the map, like I said, is it a metro map or is it a map for navigation that you need a lot of details, right, the scale and everything. Resources, what are your resources? What tools are available to you? So you should consider that. Then phenomenon, what is it that you're going to map that affects the kind of map that we choose to make? Is it a thematic map or are you going to make a topographic map? Are you going to map population in an urban area or are you going to map land use or types of vegetation in a forest or in some rural area? So that affects what kind of map you should aim for. Media of presentation is something that we are going to talk about a lot in the last week. Are you going to print the map or is it going to be used on the screen? These are some of the things, or different tools. Is it going to be an interactive map or a static map? So these are the things you should take into account, and based on that, you can then answer what would make a map good. Last year, when I was teaching this course for the first time, I found this book, The Cartographers. It's actually a novel by Peng Shepherd. but this quote is coming from the book. The world is a canvas, and we are the artists who bring it to life through our maps. So one theme that we would like to highlight in this course is that it's not just a mechanical GIS course and you would just put the data there, export the map as a JPG file or PNG or whatever, and you submit your assignment. We want to acknowledge and learn that cartography is an art, and it's a very specific kind of art where you can combine your creativity with technical skills you have. So let's see cartography through that. And this is something we're going to discuss in more detail next week. So I will skip it for now and go to layout design. So one of the first things that, well, when you look at the map, there are a number of things that like pop up immediately. So one of the first things you notice immediately is colors. And we are going to talk about colors a lot next week. Another thing that is very important is the layout, so the placement of things. Where do you place your map elements? So where is the map itself? Where do you put your title? Where do you put the legend? So that's another thing that immediately like affects how people perceive your map. So there are a number of guidelines how you can read cartography book. You can see good examples and see there are some guidelines how you should plan your layout. But a good approach, so I cannot tell you what is a good layout because that really depends on what you're mapping and what is the tool. Are you using Python, QGIS? How are you creating the map? But consider this. First, create a list of all the possible things you want to add to your map. And this can include the data layers. This can include the elements you may want to add to your map. And then make the list a bit shorter. Think twice. Like many of you said, it's good to keep things light and not too crowded. So think again, like, do I really need to have this element in my map? If I don't have it, would it like affect how readable the map is? Then you can just come up probably with a shorter list of things you want to include in your map. And then just take a piece of paper before, or whatever device you're more comfortable making a sketch on. Just make a sketch of your map. Just imagine, okay, I put the title here. I would like to put the legend here. So make some sketches of your map before you get started with creating the map. Think also which elements need to be emphasized. Sometimes, depending on the map and the data, something might be super important, like the title or the legend. Is it the legend that like the reader should really refer to all the time to see what they're looking at? Then you may want to emphasize it, and that should be emphasized in the size, in where you have placed it. So these are the factors you should take into consideration. And then very often you end up just reconfiguring your map, moving things around. And of course, you should look at good examples, ask people for opinion, and then just, so it's a iterative process in which you come up with a sketch, you just improve it until you have a good map. So these are a few examples that you will see in cartography course. So you can see how things are placed. This is a title. Probably we can add a legend in that box. So depending on where things are placed, the map can look very different right away. You can also be creative. This is a very simple example, old example, but there was a map of, in one of the cartography books, there was a map of disappearing birds. That was the title of the map. I guess it was about birds which are going extinct. So you could play with the title in different ways. So you're telling a narrative with your map, and you can use every element to improve that narrative. So doing some things like that. Someone might like that, so it's a matter of taste. Someone may not, or depends what kind of map for who you're making the map. But there are things you can do with the elements to help convey the message, the narrative you want to convey with your map. We talked about graphic variables or visual variables. These are also things that affect how the map looks like a lot. One thing that you will see very often in books, and there are different versions of this, is that, well, it came up in your comments that too much is too much. And depending on visual variables, there are a number of different variables you can use without really bothering the reader. So if you're using sizes to distinguish certain things, if you have like 20 different sizes, then it's very hard for people. They have to constantly look at the legend. And even that would be very complicated. So if you want to keep it simple, you should go for around 4 or 5 different sizes in your map. If you want to use different textures For example, for areas, it's recommended to go for a number around 5. Of course, these are not absolute values, but just keep in mind that if you have too many classes, then it might be very hard for the reader to use your map. So try to come up with more creative ideas of visualizing your data. We are going to revisit the color in cartography next week, but since you're already making a map this week, just be careful with the colors you choose. Try to do it in a creative way. So creativity is the main thing today for this week, because we will cover the color theory next week. Then we can see what are the guidelines, how to choose colors more professionally. But color, I guess we all agree that it's an important part of maps. So try to do your best in your map this week. Yeah, so a lot of the materials we went through now are from these cartography books. I didn't mention at the beginning, for this book you don't need any specific book. So what is enough is to just follow the materials that we publish on the course's website and the slides. But of course we have references, so many of this come from the books. So if you want to read more, these are the sources. Yeah, so sorry if this was a bit monotonic. It was the first lecture. There was a lot to cover, but hopefully we will have a more interactive session after the break. And I can see that Mikael is already here. So we can maybe take a 10-minute break and then come back here and continue with Mikael. Yeah.